everyone! We are here to present our experiment on projectile motion using a catapult. So our main goal was to find out how the launch angle, which is we call theta, affects the horizontal range, which we call a sub x, and the maximum height, which we call a sub y. So we kept the launch force the same for all tests so that the only factor changing was the angle of release.
In projectile motion, the path of an object is affected by two components: horizontal motion and vertical motion. The horizontal range, a sub x, can be predicted by the formula a sub x is equals to v naught squared over g times sine of 2 theta. This means the range depends on the sine of 2 times the launch angle. The maximum range happens at about 45 degrees when launch and landing heights are equal. The maximum height, a sub y, follows the formula a sub y is equals to v naught squared times sine squared theta divided by 2g. This means the height increases as the angle increases, reaching its maximum at 90 degrees.
We used a small wooden catapult with non-adjustable arm and tested 3 angles: 30 degrees, 50 degrees, and 80 degrees. We set the same pullback distance for every shot to keep the launch speed, v naught, constant. For each angle, we launched the same projectile 3 times. We measured horizontal range, a sub x, from the launch point to where the projectile first touched the ground. Maximum height, a sub y, by reviewing video recordings and measuring the peak height from a vertical scale in the background. We recorded all measurements, calculated the average for each angle, and compared them with theoretical predictions.
Our results showed clear patterns. At 50 degrees, the range a sub x was shorter, and the height a sub y was the lowest. At 50 degrees, the range was the farthest among all tested angles. At 80 degrees, the range was much shorter, but the height was the highest. When we plotted range versus angle, the graph showed a peak near 50 degrees, close to the predicted maximum of 45 degrees. When we plotted height versus angle, the graph showed a steady increase in angle, matching the theory.
From our experiment, we learned that launch angle strongly affects both the range and height of a projectile. The greatest range happened at an angle close to 45 degrees, and the greatest height happened at the steepest angle tested, which was 80 degrees. Our result matched the predictions of projectile motion formulas. Small differences were likely due to air resistance, slightly variation in launch angle, and measurement errors. Overall, for maximum distance, a projectile should be launched at around 45 degrees, and for maximum height, a much steeper angle is needed.